Impressive, right? Yes. These images are from a place in Venezuela called Catatumbo, where the lightning never stops. So today we're going to talk about lightning, because as you can see, this phenomenon is really interesting, making that even in these days, the scientists are still in the search of how this lightning works. What is a lightning? A lightning strike is defined as an electric discharge between the atmosphere and the earth. So, in the simplest way to understand this, a lightning is an liberation of energy of the air that goes to the earth. And with this in mind, we can go to the next question. That is, how is a lightning made? Okay, first, we need to know that the clouds are small dust-borne ice crystal and water molecules, and during a storm the air is moving around, making these particles collide. So, one theory says that some negative charge particles of the upward moving water molecules get transferred to the downward moving heavier particles, making the top of the cloud more positive charge and the bottom more negative charge. So, now, the electrons that are near to the surface repel with the bottom side of the cloud because, as we know, same charges repel each other, and with this, the surface becomes overall positive charges, making a strong electric field between the cloud and the surface. And if we remember, an electric field is how much force and in what direction a positive charge will go. So, in this case, it will be upward to the cloud. And when the difference of charges builds up enough, the lightning process begins. Now we have 4 types of lightning. Negative lightning. This is the most common type of lightning. In this, the electric field grows strong enough that an invisible channel of negative charge called stepped ladder begins to go to the surface with a velocity of 50 meters per microsecond. At the same time, the upward moving of positive charge called streamer goes up, and when they meet, they provoke the flash that we know and we see. So, you can imagine that this provoke a huge liberation of energy, but also provoke a great amount of heat that in average runs the 25,000 Celsius degrees. This is so much heat. Only for you can know, the 25,000 Celsius degrees is almost 5 times hotter than the surface of the sun. So this means that the lightning is hot. And it receives the name of negative lightning because the charge goes from the negative bottom part of the cloud to the ground. The positive lightning is a less common type of lightning, that instead of the negative, this starts from the top side of the cloud, making a net transfer of positive charge from the top side of the cloud to the ground. So, this means that it needs to travel more across the air to reach the ground. So there is more charge separation, making that the strikes being up to 10 times stronger than the negative. This means that these strikes can break apart molecules on the atmosphere into ions that will collide with other molecules that are around there, that it can be hydrogen or oxygen. And when this happens, it causes a photons of red lights that is being known as red sprites, that it only lasts milliseconds. There is one less common type of lightning that is being called blue jet. This happens when a huge amount of positive charge go upward to neutralize the charge in the cloud. The blue jets can be up to 40 km large, but it also only lasts milliseconds. And the scientist believes that the blue color is being because the ionized nitrogen molecules. A fun fact is that the blue jets do not appear to be directly triggered by lightning. Instead, it's believed that it occurred from the strong hail activity in thunderstorm. The first blue jet was seen in October 21 of 1989. This kind of phenomena is only been recorded about 100 times only, in the past years, making that nowadays it still be a mystery for the scientists. The ball lightning. This is a stranger type of lightning, and also the one that have less stories, making that some scientists deny their existence. But we are going to focus on the postulated theories about the ball lightning. One says that ball lightning occurs for ions made by a lightning strike near a glass, making the ions group on one side of the glass and create an electric field exciting air molecules on the other side, which will release photons and create a glow that can be yellow, orange, red, or blue. The other theory is based that elements in soil are the cause. In 2012, China recorded the first video of ball lightning, in which they monitor the light emitted and discovered that it contains silicon, iron, and calcium, and all of these elements are found in soil. So the theory says that a ball lightning occurs when a lightning strike vaporizes the soil silicate compounds that react with the atmosphere and create the ball lightning. These phenomena in many cases are confused with UFOs for the way it moves, and also is believed that they are mini black holes. Now we're going to make an exercise to have this more clear. Okay, the exercise says, during lightning strike from cloud to the ground, current as high as 25,000 amperes can occur and last for about 40 microseconds. And the questions are: A. How much charge is transferred from the cloud to the earth during such a strike? And B. It says that we have to think and investigate, does the lightning carry a huge or small charge? Okay, to solve this problem we have to see first the dates they give us. We have that the current is 25,000 amperes and the time is 40 microseconds. That converted to seconds is 40 for 10 to the minus 6 seconds. So then, if we remember, the current is defined as the change of the charge over the time. So from this equation we can solve for the charge. So we have to pass the time multiplying the current, and then we have to substitute the values that we have. So at the end it will be the current for the time. So we have 25,000 amperes and 40 for 10 to the minus 6 seconds. Solving this, we had to result as 1 ampere for second, that is the same as 1 coulomb. So sorry for my mistake, I divide an ampere over the second, but that's not correct. It's an ampere for the second, and that's the same as 1 coulomb. And now, solving for the next question, that is think and investigate, does the lightning carry a huge or small charge? Okay, after investigate we can find that it is a small charge because usually the lightning charge is about 15 coulombs, and we have here only one. And also the average current of a lightning is from 5 kiloamperes to 200 kiloamperes, and in this case we have only 25,000 amperes, so it is pretty low charge. If during a storm your hair stands up, it will be a bad sign for you. This means that the positive charge are rising through you, reaching towards the negative charge part of the storm, and that's not a good sight for you. Your best bet is to get yourself immediately indoors. One more fact is that if you can hear a thunder, you are within 10 miles or 16 kilometers away of a storm and can be struck by lightning. So you have to seek shelter and avoid situations in which you may be vulnerable. The last fact I'm going to tell you about is that if you have an umbrella, you can increase your chances of being struck by lightning if it makes you the tallest object in the area. To finish this video, I would like to make a resume of all the things we have seen. First, what is a lightning strike? At the beginning of the video, we defined a lightning strike as an electric discharge between the atmosphere and the Earth. Then, we defined how is a lightning made, and we said that one theory said that some negative charged particles of the upward moving water molecules get transferred to the downward moving heavier particles, making the top of the cloud more positive charge and the bottom more negative charge. So, with this, the electrons that are near to the surface repel with the bottom side of the cloud, because as we know, some same charges repel each other, and with this the surface become overall positive charge, making a strong field between the cloud and the surface. So then, when the differences of charges builds up enough, the lighting process begins, and we said that we have 4 types of lighting. The first one, that is the most common type of lighting, is the negative lighting. This is when an invisible channel of negative charge called stepper ladder begins to go to the surface, and one that goes upward to the cloud, that is called streamer, goes up, and when they meet, they provoke the flash that we know, and this provoke a huge liberation of energy that goes around 25,000 Celsius degrees. Then we have the positive lighting. This is a less common type of lighting because this begins on the top side of the cloud and goes to the surface, making that the charge needs to travel more across the earth to reach the ground, so there is more charge of separation, making the positive lighting strikes being up to 10 times stronger than the negative. In this type of lighting, it happens that sometimes the the streaks break the ions on the atmosphere, and these collide with other molecules like hydrogen and oxygen, and causes proton of red lighting that is called red sprites. This only lasts milliseconds. Then we see the blue jet. This happens when a huge amount of positive charge go upward to neutralize the charge in the cloud. The blue jets can be up to 40 km large, and it also only lasts a millisecond. And we said that the scientists believe that the blue color is because they ionize nitrogen molecules. And for last, we have the ball lighting. For this we have 2 theories. One says that the ball lighting occurs for ions made by a lightning strike near a glass, making that the ions group in one side and create an electric field, exciting air molecules to the other side, which will release photons and create a glow that can be yellow, orange, red, or blue. The other theory is based that the elements in salt are the cause. As we know, in 2012, China recorded the first video of ball lighting, in which they monitored the light emitted and discovered that it contains silicon, iron, and calcium, and all of these elements are found in soil. So the theory says that a ball lighting occurs when a lightning strike vaporizes the soil silicate compounds that react with the atmosphere and create ball lighting. So, as a conclusion, we can see that the lightning strikes are pretty interesting, and we have a lot to understand of them yet. So, thanks for your attention, and I hope you enjoyed the video. Thanks. Goodbye.